on the records and then okay. Now this one is on Java. Okay. Okay, so today we'll talk about generics and we'll see the practical examples also where we should use and how we should use. Okay. Are you able to see my screen? Okay. So the whole idea of generic was to define the algorithm once, and that can be independent of any of the specific type. So far, what we have been doing is any class that we define, let's say class, let's say example, we specifically provide the type for each of the members or the type of each of the method parameters. But what generics is going to provide us is I can write the algorithm once that will be independent of the any specific type. And that's how powerful this Java generics are. Now, later on, once you once you have defined that generic class, we'll use it for a variety of data types. So once the definition is done, once the class is defined in such a way that uh, I can use with any data type, later on, while using, I have to specify the data type. Okay, the most impacted feature of Java is the collection framework. So Java Generics has impacted collection framework the most. Okay, we'll move on. So generic, what here means is that parameterized type. Okay, so it's like for whatever term, whether it is associated with classes, interfaces, or methods, if if we say that generic classes, if we say that generic interfaces, what it means is that those class definition will be of parameterized type, and we'll see examples on how exactly that is done. Okay, and right, same, right? So the classes which will follow the generic pattern or the classes which will have the parameterized type will call generic class, same interface, and generic methods. We'll move on. First thing is why generic came, right? Why can't we deal with just the objects? Okay. Why can't we deal with just the objects? Okay. So the question is what used to happen in the pre-generic era? So this Java generic got introduced in 1.5, JDK 1.5. And before that, what used to happen? So everywhere the object was used as a reference. Okay, instead of providing the specific type, we use the supermost class because supermost class or the base class can hold the address of the child class. And that's how it used to happen in the pre-generic era. All the generalized classes, interfaces, and methods, they were written with the object. The problem with that approach was there was no type safety. That was one. And there has to be explicit type conversion. Okay, so basically, we'll see that also in the example. So whenever you deal with object, in order to access your class members, you have to typecast it before using it. And that's what has been omitted by Java generics. Okay, so and this is the way, right? This is one way that type safety was added to Java. One more thing we'll see. Okay, so let's take a look at, right, very simple generic example. The type parameterization that needs to be declared with the class must appear after the class name. So this was the old syntax, class and the class name. After that, whatever number of type parameters that we want, we can declare as many number that we want. And within that, we can use, right? Now that we have declared this is declaration. Okay, what are the condition or what are the different parameter type that can be used within this class or any of its parent classes. We'll see all that, right? The hierarchy and all we'll see. What I'm saying is at this point, the type is getting declared. Remember this point, okay? Now, the next onwards, I can use that specific type while let's say this is my member variable of this gen class. In the constructor also, I'm using the same type that was declared. And then so on, right? In the method return type also I'm using, and I can use anywhere as I want. Okay, same. These instances of that is also used here. Now, one thing that was made very clear, the type that you pass, type parameters, will only be of reference type. Type parameters will only be of reference type. Okay, so now let's take a look at, I think this is a simple example. What it will does is, the way we will initialize it is, in main method, I can do it something like gen integer, and then let's say something like it was an integer object that was created. And the same way we were instantiating the class gen integer. And in constructor, I can pass some value of integer type. Let's say I'm passing it as 80. I can do it like this. Okay, this is the way I can use this generic class. And after that, what I can do, I can keep on calling obj dot all the class methods that were declared. So for example, I can call get obj, and what it will return? It will return an integer. The return type of that will be integer, which was declared, which were passed as an argument to this class. So I can simply store the value as int v equals to obj dot get integer object dot get object. I can do that. Also, I can also, and what will this return? What should be the value of v? It will return the value as 80. That was passed here. Same, instead of integer, I can pass it I can pass a string. Okay, let's say.
Hello, Abhishek.
Yes.
The line which you wrote, right? Int equal to v and object dot get object.
Uh-huh.
So that integer will be primitive type. Uh,
Yes, I mean that
okay.
auto boxing, right? Unboxing will happen.
Okay. Yeah.
Unboxing will happen, right? Ideally, I can write it integer because it's of reference type. But yeah, the unboxing will happen here. Okay.
Okay.
Now, what I'm saying is string, and here I can pass something like hello generics. Same thing here, string, let's say str equals to same str object, I can call the get object. And this will return the string. The value of this string will be hello generics that was passed here. That was passed here. Also, I can also call, for example, str obj dot so type. Okay, I can also call this, and this will go ahead and print that. Okay, what's the type of this? Okay, so it will print as what does this method return? In case of string, it will return java dot lang dot string. Okay, that's what it will return. In case of integer, it will return java dot lang dot integer. Okay, now see how powerful it is, right? Now I can passing of any type, any reference type. And these are from the Java APIs, these are from the library, but I can pass my own created references to this. And the objects can be set and get. Set using constructor and then get using the get method. Irrespective of type. Maybe I can use it to create a store kind of thing. Okay. Here I can create some custom data structure. Okay. I can use it like this. Okay. So we should understand the power of generics. I can use it with any type that was not even that was not even defined. Imagine this gen class was written today, or let's say written today. You can create a new class maybe 1 month down the line, right? You can create a new class and use this gen class and pass those reference type. That's the power of generics. Any questions so far? Okay, we'll move on, right? So what's the key takeaway from this? The takeaway was, okay. So, so takeaway is, if you see, we get to see both the examples, string as well as the string as well as the integer, both the examples. The takeaways are these extra types, extra type or a specific type of gen classes are not actually created. Okay, they do not, this type does not exist during runtime. Okay, what compiler achieved by this is compiler actually, actually removes all the type information that you have provided, and it just, okay, and it substitute that with the necessary class. So imagine compiler is able to hold this structure and transform into a common pattern in which these specific types do not exist during runtime. And this is applicable for all your collections. Whatever collection that you create, for example, array list of string, all that, okay, all that information gets removed during compile time. Okay, this is very important. Now, the feature of removing this generic type information and substituting with necessary cast, this is called as type eraser. This is called as type eraser. And this happens only with the, right? This is used, type eraser as a concept only gets used in the generics. Okay. Fair enough. So takeaways are, compiler do not actually create separate version of gen class which will be take of which will take integer. So I mean, as a human, what we can think of is, whenever gen of integer was done, what compiler would have done was they could have replaced all t with integer, and then it works accordingly. Conceptually, as a human, it's good to think that way because that's the way the behavior of the class becomes. But compiler do not think that way. Compiler do not keep it that way. Compiler does the type eraser and then replaces it with the necessary casts wherever needed. For example, where the cast would have been needed at this point. At this point, compiler will add the cast. At this point, compiler will add the cast. Because imagine this string as a type is removed. Imagine this string as a type is removed. String as a type is removed, which means this is a normal object creation of gen class, correct? By just passing this as a constructor, by passing the string as a constructor. And this is normal method invocation. but the return type of it, right, will be the same as whatever was the type that was erased. And that's why the conversion will happen like this. Fair enough? Okay, moving on. Now, let's take another example. Okay, here what I'm doing is I have the same gen class. I'm just providing the type parameter here, type argument here is integer. And what I am doing here is, while instantiating, creating the object, I'm passing it as a double. Is it allowed? The answer is no. This is invalid. The answer is that this is invalid. Okay. You will always instantiate with the same type argument that was passed, okay, here, okay, or these two should have the parent child relationship, just like we used to do in non-generic word. So parent can hold the references of the child, that will still hold true, and we'll see how the parent can be written, how the interface or how the hierarchy can be created. But here, if you see integer and double, these are two different type. So two different type arguments cannot be added to the reference and to the object creation. Okay, so that with the new you cannot do it. Okay, so this
So,
is.
so Abhishek, when you mentioned that parent child, right? So the left side always has to be that parent, or it can be child also. Like,
Okay, I think I have solved this before. I have, okay, I
okay,
have taken the example before, but I'll take you, all right, take you to that example again.
okay, for example, currently there is a integer,
Mm-hmm.
so we can only keep uh, means can we keep that gen and then generic sign and then long,
Okay, I'll
or we
tell
have
you.
to only keep the integer or byte or
I'll tell
short?
you. I'll tell you. I'll
Okay.
tell you. So, one thing is you don't consider the hierarchy between the type. That is not right. Right. That is not at all related. So, what I'm saying is hierarchy. What I mean by hierarchy is the class hierarchy, not the type hierarchy. Okay, and we have that type hierarchy examples or hierarchy examples for the generic classes. We'll show you that. What I mean is you don't, right, while seeing the statement of object creation, you don't have to think about the types. Type, you need to ensure whatever is there on the left, okay, left side has to be there on the right side. That's it. Okay, got it? Clear? Whatever type that is mentioned on the left side needs to be there on the right side. Okay. What I
Yeah,
mean by hierarchy is this class hierarchy. Imagine there is another class, Gen 2, which extends Gen.
yeah. Also, I believe if we just mention on the left side, the compiler automatically infer, right? We can also keep that right side as a empty also.
Yeah, that type inference is there. Type inference happens. Okay.
Okay, okay.
Type inference happens, but we'll talk about all that. Okay. Let's not
Sure,
jump
sure.
onto the
Hmm.
jump onto it. Okay.
Sure.
What we need to ensure is that whatever type information that is passed, okay, with the reference type, we have to use the same type information here. Then only the statements will be valid. And all these invalid statements, all these statements will get called at compile time. Just think of Java generics as a compile time safety check. That's it. Okay, it remains up to the compilation time only. If you think right in those terms, that will make a lot of things clearer, a lot of doubts clearer. Okay. I already mentioned. So generic always work with reference type. So this statement is also invalid. Gen, instead of passing integer, can I use it with int or any primitive data type? No, that is not allowed. We should not use it because it always works with the reference type. Generic always works with the reference type. Clear? Now we'll move on. Can I have, okay, so can I assign, right, different version of same generic type? For example, I created gen of integer, that is I object. I took, right, I passed 80 in the constructor. Same, I created gen of string. I passed some string as a constructor to that class. Now, can I do the assignment, address assignment? And the answer is no, that is not allowed. And what we are saying is that reference of different version, because this is the integer version of gen class, this is the string version of gen class, and the both the types, their types are differ, and that's when the assignment cannot be done. Comparison you can do. Okay, comparison, address comparison I can do with anything, but that is meaningless in this case. And even the assignment cannot be done. Okay, let's move on. We'll take a look at how exactly generic improve the type safety. Okay, so let's say, right? In generic world, I was saying everything can be replaced with object. Everything, everything, everything. All the things in the previous gen example, they have been replaced with object. Okay. Now we'll see what will happen when, what will happen. Okay. Okay. What will happen? Let's say this is the demo class that uses the non-gen that was created here. Okay, that it just uses, and if you see, it created the reference. Now it instantiated and passed the constructor because okay. Now if we zoom in a bit, right? If we zoom in a bit, this is of integer type. This is of basically int type. Here constructor takes right. Constructor's parameter declaration is of object type. And again, here also, auto boxing will happen. This int will get converted to integer. And then the reference of this integer will get stored here in the obj. Okay, same thing. I'll just try to give you the example that I have. 1000. Okay, in this object, whenever we do up to this, what will happen? We got a reference of obj. Obj will hold address of another object. So the 80 that or the 60 that was passed, that will be wrapped in an integer object. Let's say this is your integer object. And this 2000 will be stored here. And I object is another reference variable which will store the address of this guy. Okay. This is what is actually happening here. So 60 got wrapped and right in right auto box. There was an object that was created, and then this address of that got assigned to obj, and now right, this is complete. We call the so type. So type will give me what will be the value that I'll get from the so type. We'll take a look from the example itself. The critical part that we have to look is this guy, obj.get object. And here I have to do the explicit typecasting. Because this is of, right? Because we know that this obj is of integer type, I have to do the explicit typecasting. Okay. Now, next thing, same thing I created for a string, no difference. I created same for a string. I call the so type. And then here also I have to do the typecasting. The next part. This is where the blunder happens. Now, because both of them are of the same type, iobj and string obj, they belong to the same class type. They belong to non-gen. right? They belong to non-gen. I can do the assignment. Now, since I did the assignment, even if it was assigned to IOBJ, if I go and cast it to integer and try to read the value, right? Whatever I read the value, I fetch the value, I try to cast it. Okay. So it's like this is the mistake. Okay. And this is the type safety check that got introduced by the generic classes. Okay. Basically, what it means. So if we write the code in non-generic way, these type of error will happen at the runtime. Okay. In summary, these errors will happen at the runtime. But if we use the generic class, those runtime errors are converted to compile time. Okay. Fair enough. Now let's take a look at the example, right? We should also see the examples, what exactly should be the output and how exactly we can, right, do the things. So host, I'm gonna share, where is the example? Okay, let me start sharing my screen. So hope you are able to see my screen. This is the basic example I'm having. So this example is from the basic, right? The generic type, I declared the gen type, all the methods that is declared here. And in the demo, I can invoke it with string also. I can invoke it with integer also, right? I am able to do that. And if I just go ahead and run this particular, right, the output that we'll get is the same, right? The type of the type of t is in the first case integer because we had passed 60. Same in the other case, it is a string. Okay, this was the actual right, the very basic example that we had. Next, if we see the non-generic manner, non-generic, we created the same way. We declared the object. I think I showed you, and this is the same class. In the demo, we have done the right similar thing. Non-gen, I declared the integer object, and then here I'm calling the so type. Again, I have to cast it like this, and then I've declared again the string. I'm calling so type, and then I have to cast it again. Now, what we have to do is, if you see here, we are doing the assignment and we are calling it. Now, if you see, the compilation is fine. There is no compile time error. Even I am able to run it. Okay, I can run this program. Okay. Now see the exception, right? If you see, it printed the type integer, it printed the type string, but the value, right? Value was also printed. Then after that, we are seeing, if you see, this is classed, right? Class cast exception because we were trying to cast string because we assigned the string address. We assigned the string address to the integer and I'm converting it to trying to typecast to integer. And that's the runtime error that we got. Okay, and this is what is right, this is what is saved. This is what we mean by runtime error to compile time error. Fair enough. Now if you try to do the same thing, right, and here you try to do I object equals to str object, straight away you will get the compilation error straight away. Okay, so if you run, you are getting compilation error, right? If you see, string cannot be converted to the generic, right, gen integer. Fair enough. Any questions you have? This is what type safety means. Okay. Now let me show you the okay. Let me show you output we got here. Okay. Let me just navigate to this directory, idea projects, Java. Mhm. Example one. Uh, okay. Wait. Where is the demo class that I'm having? Gen demo, am I getting compiled? No, yes. Example one. Okay, okay, wait. Let me go back. Let me go back and compile it for you. Java C dot space. Oh, I have to go in SRC, right? Java C dot space from example one. Da, 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 da. Okay, my bad. We have to give the -d option because I'm compiling it from a directory. Okay. Now, if we go back to this directory and see, fair enough. If you see, there was no new class that was created. The class remain as is. Okay. The class remain as is. And even if we try to use it with string, even if we try to use it with integer, there was no new, right? Compilation or during compilation, Java did not create any of the different type of gen. Okay, that's what I wanted to show from this. Fair enough. All the methods remain as is, and this is the again, right? We are just calling the right. This is the gen demo constructor, and this is the static main. Okay. Okay, because because we did not provide any constructor to this, we did not write any constructor to the gen demo class. Okay, and that's when compiler adds it. Okay, so that's the beauty of Java. Okay, we did not write any constructor, so if you do not write, compiler writes it for you. Okay, and that's what has happened here. Fair enough. Any questions? Okay, now let's, I think we did both the examples. Okay. Okay. Now let's see the third example. How we can have more than one type parameters, how we can use it. So same thing, whatever type that you want to specify, that needs to be declared here. Even later on, we'll see whatever conditions that we want to improve upon or additionally add to these type constraints. I have to do it only at one place, that is here. I should not be doing it for the generic class, I am saying, okay? For the, if your class is declared as generic, which means any type parameter that you declare or the any constraint on the type parameter that you add, they have to be done at the right, at the declaration time. And this is the type declaration we call. Okay, remember this thing. Now, what I did, we have got the same two members, T and V, both the type, right? Type, exact data type of both of these, right, are unknown. For the both of these types are unknown. Both of these parameters are unknown. Same, I took two argument constructor, and then I'm not having any default constructor for this, and I'm just written the fetch data or get object method for both of them, T as well as V. And here I'm doing the same. I'm just declaring, showing the type of that particular, both the parameters. Now, in the gen demo, right, this is the way we pass. So whenever we try to create the instances of generic class, this is the syntax. You provide the class name, you provide the angle bracket, and then you provide the number of, you need to specify the number of types that was declared in the this guy. Okay. So same thing, 2gen was declared. I'm passing one as integer, another as a string, and the outcome is same. I'm calling so types. And if you see, there is no type conversion at any places. Fair enough. If we try to run this, do I have any question? Okay, I think there are, okay. No questions, right? Okay. Cool. So if you see, I try to run and I'm getting type of T is again integer, type of V is again string, and then same, right? 60 and generics I was passing. I'm getting those values printed. Fair enough. Now, okay, so I think so far so good. Let's jump back to the slides. Any questions so far from anybody? I didn't hear yes or no, so that's why. Okay. Now, this is what I showed you, a generic class with two type parameters, right? Similarly, you can have n number of parameters that you want, that you need. Okay, you can get it declared. Next is, what's the general form of generic class? Again, class declaration. You used to have class and the class name and this curly braces. You need to provide the type parameter list. What all types that you are going to use within the class. That is right. That will be declared as a new type. Same, for instance, creation we have already seen. We'll use the class name, argument list will pass, and this is the var name that we used to provide. And same class name and the arg list, these two has to be same. And the constructor that needed, right? That the constructor argument that we need to pass. Fair enough. Now, let's say I have to compute the average. I have to compute the average. So what I'm doing is of all the, let's say, numbers. So I'm going to create a generic class because average can be computed the same way for integers, float, anything, right? Double or anyone. Let's say I have to do that. What I can do, I can take, right, arrays, those type arrays, and I have declared that type, right? Exactly, I need one type to compute the average. I've provided the constructor which will take the array reference as an argument, and I'm assigning the references. Now imagine I'm trying to compute the average, and we know that average of any number can be casted to double value. So what I'm doing, this is generic loop, and this is what I'm doing, num of I to double value. Okay, num of I to double value, and that's when the compilation will come to you, compiler will come to you and ask, hey, you have declared a type which has no constraint. Now T can be of any type, but the double value is something which is not applicable to all the classes. Okay, what it means is that any method that you want to call with unrestricted type parameter, those method needs to be present in the either in the supermost class of Java, or it should be present in the constraint that you are providing. Either of the place it needs to be present, otherwise you cannot invoke. So because we haven't added constraint on T, it is called unbounded. Okay, and hence double value is not at all applicable, and hence this code will not compile. Any questions? My intent was same. My intent was to compute the average. My intent was to compute the average of all the numbers. But those restrictions, right? Those restrictions are not added. And that's why we are getting error here. There is nothing else wrong within this set of code. Okay. Now, what it introduced is the bounded type. What do we mean by bounded type? We can add some constraint on the type parameter. We can add some constraint on the type parameter, and that too only during declaration. And what this constraint is, I should be able to pass any type parameter which extends this number. Now, if we see all the classes, integer, float, double, they are of number type. They all extend the base class that is called number. Okay. So if I just put the constraint, if I add a bound to my type, what I'll get? This code will compile, because now they will check that whether this method, double value method, belongs to the type that was added here. Okay, that was added here. So what exactly this means, right? What are the values of t I can give? T can be of any subclass. Ouch. Just a second. I think my screen sharing would have stopped. Am I able to? Are you able to see my screen? Yes, no? No, right? Okay. Why? S- Stop share. It says stop. Okay, let me stop sharing. Let me start sharing again. Share. Okay. Share screen. Start broadcast. Okay. Hmm. Okay. So what I was mentioning, that T can be of any child class or any subclass of class of number. Fair enough. Any questions? This program will compile. The way to use this is again, sorry. I will create an array. Okay, let's take this example, right? Because let's take a look at this example. Okay, so let me stop sharing. There are some some restrictions there, so that's why I wanted to show you. Now, let's take a look at the example number 4. Okay, so because this will not compile, I have got another example which will give you the same stat class which we had. Okay, I put the extents number, and this is the one. Now the interesting part is here. Can I declare, okay, one thing. Can I declare an int array here and pass new nums? Can I declare an int array here and pass? Answer, please. Can I use it to pass in this guy? I need answers. And the answer is no. Answer is no, because whenever I declared integer as a, right, integer is going to be my type argument, then by default, the stat class, by default, The stat class, if you see, this became of, this will always take reference of integer objects. There is a difference between int, right? Int array and integer arrays, right? There is a difference between int array and integer array in Java. And the differences are subtle. Okay? Differences are subtle. So I cannot pass, let me just, I cannot pass it. This will give me the compilation error. Got it? Got it? Either they will say that, okay, change it to int array, or this calling is wrong. Fair enough. So what I wanted to show you is that whenever I'm using generic type, I have to always pass in, let's say even the references or arrays, right? I have to pass all of that of the reference type. Fair enough. Now, let's see this example. Other than that, I think other things are same, right? So it's like this is your integer array. I'm calling average. I'll get the average. I'm using it for double. I'm passing the double array, right? I'll get it. Now, same thing. Now, can I do it for string? Will this code compile? So let's first run this part. Okay. I'm just getting the averages of both of them. Now, what if I try to do the average of this guy? And compiler will throw error, right? That's what is happening. The string is not within the bounds of type variable t. And that's why what we mean by the boundary. Okay. Here we are specifying a boundary for t, which is this, right? Whenever you see extends, it becomes the upper bound, which means you can have t of any child of number. And that's what it mean by we have kept a ceiling. We have kept a upper bound for whatever type that we are declaring here. Any questions so far? No? Okay. Now, let me come back to the example. Okay. We got it clear? T can be of any subclass and will okay. So next is, imagine I have to compare the averages. So let's say I got these two averages, the averages from either of these two, okay? Either of double or, let's say, right? I got averages from either of double or number or integer. What if I have to compare the averages, the outcome that has come? Can I write the function like this? Yes, no? Can I? Sorry, who was?
Yes.
Okay. Can I hear answer from Manjunath as well? Manjunath, what do you feel? Can I write if I have to compare two averages of any type, right? For example, whether the average is coming from float, from let's say integer, from long, from double, anything.
Here, stats of T, I think I'm not getting the context fully. I think the class will have one type of thing. So,
Stat.
suppose T is,
This is your stat class.
okay, suppose it's integer once. And can you scroll down a bit? Yeah, if suppose OB is integer and this dot average will be double in that case. I think there will be compile time error, I guess.
No. This dot average again, right? So average method's return type is double in both the cases, right? Even when you call from OB or whether you call from this.
But t should be double in that case. T should be double, then it will work. If t is integer, in that case, it may not work.
No. Okay. Why the confusion is happening? So whenever we try to instantiate, there is no t. Okay. There is no t. What happened? Whenever we try to instantiate, for example, in our case, we took stats of integer. Okay. And then there was something else, which is stats of double. Now, okay, let's say integer object. Let's say this is double object. Okay. And I got the right proper instantiation, new stats integer. And then I'm passing the right set of array here. Same for double. I'm doing the instantiation stats of, and this is also double here, right? Now let's say I did this. So your method, whether it is this or whether it is, there was some other method that used to be, right? So in my previous example, all these t and v, whenever you declared something like 2gen, integer, comma string, all your t and v is gone, right? That's how we should think of. Okay. To obj, new, same thing, right? 2gen, integer, comma string. Okay, let's say I did it like this, and let's say I passed it. Let's say I passed 40, comma, hello. Let's say I did this. So whenever I'm talking about this line, all this type is gone. Although I showed you, I think that might be the confusion point. As a human, what we need to think is there is no T and V right now. All we have is 2gen class that is having data types. Okay, forget about this type, forget about this type. And then imagine it is an integer, it is a string, and again, right? So everywhere integer, string, and so on, right? We got everywhere replaced. Okay, let's assume it that way. And then what I am proposing is, let's say I have to, so at least this part is clear. There is no T
Yes.
and T. Okay. What I'm proposing is, let's say in this case, I had to compute the average because I was having the array already. And because average will be fraction, I took the data type as double. Average will be a fraction, so I took the data type as double. Now what I'm saying is, what if I have to compare the average of two stats? So I can write a new method, that comparison also. Now, in order to compare that, can I write syntax like this? And what happens if I give the syntax like this? Okay. Now let's imagine this OB.
No, the point is t extends number is not there, right? In that case,
Okay. That confusion. So this restriction has to be only at the time of declaration. I already covered. You should not be anywhere. I didn't put whether t should be extending something or not. Okay. This declaration or any restriction that you are gonna have with the types will only happen at the declaration, and declaration for the generic class is happening just beside the class name. If you see this is your type declaration. And any restrictions, right? Plus, if you want to put any restriction. Okay. So declaration and restriction, whatever you want to put, you have to do it at this place only. Nowhere else I'm going to have it. Nowhere else, right? I have the other class body also. I should have mentioned it. No. Only at the type parameter, wherever you are declaring, only the restriction has to be at that place. Fair enough? At least clear at that up to that. Okay. Fair enough? Clear? Now, what I'm saying is, again, let's take a look at this method again. Now, I can use, right? Here I'm using the type that was declared for the stats class. Can I have a reference of the same class, okay, and pass it, okay, to the current one? So basically, can I have the reference of stats with T, okay, and pass that to compare? Now, because this is a instance method. So I'll be calling on some instance, right? So for example, in this example, if I show you I obj dot, I will be calling something like same avg. Okay. And here I have an option to pass some type, right? Some reference, not type, some reference of any type. Now with this method declaration, with method definition, sorry. Okay. I will only be use or compare the object or I object. So I object is of type what? Stats of integer. Then I can only be pass the reference of stats integer here. Okay. Okay. You got it? Here, if I write the method like this, I can only pass the reference of stats of integer. I will not be able to pass stats of double in this case. This will give me compilation error altogether. Okay? Got it? The problem with this same average method is whatever object that you pick, whatever right reference that you pick, or on whichever object that you are making a same average call, the comparison will happen against the same type reference. Comparison will happen against the object of the same type reference, which means I will only be able to compare the stats of integer array with another stats of another integer array. Okay. But in practically, I should be able to compare against double also. What if the averages could be same for both the cases? Because I'm having the average represented in the same data type for all the different all the different type parameter objects. I'm representing everything in double, so I should be able to compare it. And that's the reason, okay, this will not work in both the cases, and I'll show you, right? I'll show you practically. So what this will be able to do is it will compare the stats of integer versus stats of integer, stats of double versus stat of double. Okay. So first let's reach up to this point when I'm not able to do the comparison. Okay. And then we'll come to the new concept. So let me go back and now wait. Okay. So what I'm going to do is I'm going to use okay. So let me just close everything. Sorry. I can go back to this. What I'm saying is close other tabs, right? So now let's see this also. So what I'm saying is stats. I got this. I wrote it like this. Okay. And then here in the wildcard, what I'm passing is I'm trying to pass or trying to check. Okay. Here I did the integer array. I created the stats of integer I object. I passed the double array. I created the double array. I got the average, right? I created the stats object of double. And then float also I did. I got the average, right? Now, in order to compare, right? In order to call the same average method, I'm calling with stats of integer versus stats of double. And that's what is not correct. This is compile, right? Giving me the compile time error. If I go and run this, I will get the compile time error. Incompatible type, right? Double stats of double cannot be converted to, right, stats of integer. And that's the compilation error I was talking about. Fair enough? Okay. So remember two things, right? Any issue with the generic type, you will get the compilation error unless you have write very right messy code. What I mean by this is any error that you have or any let's say bug that you encounter while writing the generic type codes will only be caught will or can be caught during compile time. Okay, unless you have written very complicated code and unless you don't even understand the all the generic syntaxes. What I'm trying to show here is same average. If you see, it was declared like it will take the same type parameter, okay, of the same. So if I do it, okay, if I let it compile, I have to create another one. Integer array, okay. Yeah, new nums equals to, let's say I'm taking 2, 3, 4, 5, 6. Okay. I can take off any size, right? Let's say 7. Good. This is also fine. Now, what I'm going to do is stats of integer. Okay. New I objects, or actually new shouldn't be used. I pardon about my naming. A integer objects equals to new stats, and then I'm passing integer, and then I'm passing enum into the constructor. Now, what I will have is double, let's say v1, vnums equals to I objects dot average. I can do that. And then, sorry, I think I should be doing AI objects of average. And what I'm going to do is, and then AI object. Now, here, if I try to compare or pass AI object, there is no compilation error with the code. Got it? But I'm still continue to getting the compilation error for this. Let's say I commented it. And then I try to run it. Wait, not bound with the, where is this bound demo? Oh. Bound? Why bound? I'm saying wildcard to go and run, right? Wildcard to go and run. What's the error? Okay. So what I'm saying is, if you see, I think the message I put is wrong. So message I should have put here is in the comparison averages of AI object. Okay. Now, if you see, I got the average of this as 3. I got the average of AI, right? New integer as 5. And I'm able to compare. Now, the problem with this method was, now you got it, right? So what is the problem with this? I can only compare with of the object of the same type. In order to, yes, can you give me, right? Yes, no? Okay. Okay, sure. Okay. Sorry, Abhinay, you are saying something? Hey, Abhinay. Hello. Abhinay, if you are speaking, you are on mute. Okay, so far clear, Manjunath?
Can you open that same average? Yeah, same average. Yeah, that method. You are just comparing the average values, right?
Yes.
But value what we are passing in the latest is the average, actual average value. So where is that linked?
Which link?
Can you go to wildcard demo?
Okay.
I think where the average is called comparison, where you called the actually passed averages. Yeah, I think I object is the actual
Yeah, I'm passing the object reference, right? Because if
AI
you
object. Can you maximize it? I think I just want to see that.
oh, sorry, I think just a second. Navigate and then view. Increase. Okay. Option. Sorry, control and then shift and then dot. Fair enough.
Can you double click on the tab, wildcard demo tab? I think it will maximize.
Oh,
No,
you
not in the. I want to maximize and see, not the font.
okay.
Yeah, I object and AI object. I just want to see it in the same line. That's the same window.
These
AI
two are
object.
object references, right?
Where is that? I can't see them, I think.
Okay. Sorry. I think these are the AI object reference here, right? Here. And
I
this is
object is integer and this is also integer. Yeah, both are of same type. Previously, when we got error, that was with respect to D object. D object is also integer.
no, D object is of double, right? If you see this, starts of double.
Okay, I think both are of same type, so it's passing. Okay.
Yep. So what this introduced me is to the something called as wildcard. Okay. How can we use wildcard as an argument? So I'm gonna remove comment this and uncomment this. And now all my code will work. So what wildcard means is giving a question mark, which means I have no restriction on the type that can come here. But if we see, the stats class has a restriction on what all type that can be passed as a type parameter. So I'm open to all the types that are allowed by stats, and this will work on with all of them. Got it? What does this mean? This is a wildcard example. And what this means is that I am open for stats, right? This method is open for taking a reference of all type of stats. Now, what type of, right? What are the different type of stats that can be created that is already mentioned while defining the type parameter? That stats can be represented along with a type which is subclass of number.
Okay, any numbers,
Yes.
fractional and integer also. Okay.
Yeah, anything. You were saying something. I think you had mentioned. Okay, sure. I didn't get Vinay. Sorry.
No. I think there was some previous conversation which you was telling. So yeah.
Okay. Okay, fair enough. So what I'm saying is, okay, so this is the wildcard example. And if you see now, even if I uncomment this, I'll be able to get this running. Okay, I'll be able to get things running. And what it means is that what I'm doing, I'm declaring integer arrays. I'm creating stats of integer, and then I'm calling average. I'm declaring another integer array. I'm calling stats of integer, right? I'm instantiating stats of integer and calling average. I'm creating double array. And then I'm creating the stats of double. If you see here, stats of double. Then I'm calling the average. After that, I created the float array and then I call the average. All the data types, I'm able to compute the average now. Now, in order to compare, right, the averages, I'm able to compare anyone with any other of them. So for example, integer with another integer with double, integer with float. Even you can compare double with float. Anything that you can compare. Clear what exactly when to use wildcard? Okay, what we need to ensure is that if you see, this is a question mark. Question mark means I do not have any restriction. And these question marks, okay, can only be done during uses of the parameter. It cannot be done like this. I cannot do something like this because here I'm defining the type parameter t. Now t is going to be my data type that will get used throughout the class. Okay, fair enough. I hope this is clear now. Okay. Now let me. Okay, so next, what we have is we are having. I think we talked about this. The solution to that was the wildcard, and this computes the generic average. Now, these bounded wildcards, right? The wildcards can be bounded, and this bound, I think it's not saving. And the bound can be of both the types, okay? The wildcard can be bounded, and that can be of two types. Either we can provide the upper bound or we can provide the lower bound. And this is the, right? Sorry, I think this example is wrong, okay? Or yeah, no, not wrong, sorry. What I'm giving is the class name that we created. So this is like stats of question mark extends. For example, I can give it something like number. Okay. Or I can use sim, right? I can use class name stats something question mark super of, let's say, integer. Okay, so these are the two different type of bounds that we can provide while writing the right wildcard, and each of them has their own use case.
Okay, so first one is only referring the child one, right?
Yes, it is
And
giving
the
x something which extends number, so that will be number which extends it is integer.
so left side is the child, right?
Yes, that's what I'm saying.
Extends
So
life. Okay.
yeah, so that's where double, right? So that's where in place of question mark, anything of this guy can come. Okay, either integer, you can use integer, you can use float, you can use double. And that's where I'm saying this is called as upper bound. You provided the upper bound on the right upper bound for the reference types, and any
If
of the subclass can be used. Any
okay,
of the subclass can be
subclass
used.
can be only used.
Yeah,
Okay.
let's say tomorrow,
If purposefully someone is using object, then that will give compile time error,
error,
right?
or
Okay.
not just object. You, let's say if somebody is using string itself,
Oh, string itself. Okay.
right? That will give a compile time error. Fair enough?
Okay. That's the different type altogether. Okay.
Yeah, it is a different type together. It does not extend. String does not extend number. So this will give me the compile time error. Now tomorrow, let's say I created my class, my number, which extends, let's say, integer. Let's say I'm just creating a specific type of integer. This also can be used with the stats, not just with the existing classes. Anything can be used which is subclass of number. You can use something like this. Got it? Clear? I hope this would be clear. Okay. So the important part is while creating a generic type, that will operate on a class hierarchy. So basically what we are saying is that all these bound needs to be provided whenever you are working with the class hierarchy. Let's say you have got a guideline written in your interface. Now, all the subclasses, all the classes which will implement those interface, that interface will implement those classes, otherwise they will be abstract. So within the generic class, let's say I'm writing a generic algorithm where I will call the interface methods. I will use the interface methods. And those generic algorithms can be used with different, right? With different classes which implemented the interface that I defined. Okay. So, I mean, you will get to know once you practice a lot on this, right? This will make clear. But remember one thing, this extents give you the upper bound. Super gives you the lower bound. Super, what does it mean? Super means that any class that is parent of, let's say, if I gave super as an integer, what it means is that I will be able to use integer itself. I will be able to use number also. I'll be able to use object also, and so on. Okay, so this gave us the lower bound, super, and extents give us the upper bound. Any questions? I'm happy to take.
Uh, s- so that the lower bound one, the super type T. So what will be in the left side then? Means that can be anything, object or
Okay, I declared something like stats, a method which will take an argument which is of stats, which will have, right, wildcard, which will extend the integer. So what all I can use? I can pass the reference of stats of integer itself,
okay, integer itself or short itself.
this
Short.
number itself. Does sort, I mean, does sort, so is sort superclass of integer? No, right?
Okay, okay.
It has to be a superclass.
Super class of the right side.
Superclass of this guy, yes. That's why we are
Okay, okay,
calling
okay.
lower bound.
Okay.
That's why we are calling integer as a lower bound. Whatever,
Inte-
okay?
okay. Integer as a lower bound. Okay, okay.
Okay,
Mhm. Okay. Even uh,
go ahead.
okay. Yeah, okay, fine. Only that should be of type um, integer only. Means uh, the hierarchy for integers.
Yes, upper
Okay,
hierarchy of all the parents of integer. That's it.
okay.
Parents
Okay.
of type T.
Parents.
Here, if you just see, lower bound means all the parents of type T. Here, upper bound means all the childs of type T. Let me write it down. Okay. Add page. Yes. So what I'm saying is class name. Let's say you have wildcard extends T. So what exactly you can pass? You can pass. You can pass in this. You can pass all the child of T. Similarly, let's take an example. Class name question mark super T. What it means is that in this, you can pass, not pass will not be the right word, use all the parent of T. Clear? Now it should be clear. Yes? Use. For example, let me give you the example also. Let's say Okay. Now, what I'm saying is the information about type will be declared at the class level itself for the generic class, correct? Class, let's say demo, okay? It can be declared like this, or it can be declared with a bound here also. T, let's say, extends, okay? Number. Fair enough? Or I may not have some restriction with the T here. I may not have any restriction with the T here. Still, I can have a method which will use something like demo of, right? Which will use something like, okay, let me say, okay, let me give you the right example. So let's say while using the demo class, I started using number. Okay, let's say I created an object, new demo of, let's say, right? Sorry, demo number. And let's say I passed some value here. Okay, let's say I pass some array, or let's say some array I pass. Array. Okay, now once I decided that I'm going to use number as a type parameter for this guy, what I can pass, let's say there is a method called test. I can call an object dot test by okay, passing some sort of, let's say I also have demo of, right? Demo of integer. So I can pass, let's say I object and so on. Let's say right hand side is written such a way. So I can pass I obj here. While calling the method test on an object, I can pass the I object here. Okay. And that's what we mean by, okay, wildcard, bounded wildcard. Fair enough. At least you got this idea. I'll show you in the examples also. I think to make it more clear, let me just go back. Any questions you have on this example that I'm giving? Anyone? Okay, I think Manjunath says BRV. Okay. Abhinay, any questions you have?
No, Abhishek, I'm fine.
Okay, thank you. So I'll show you the example. Let me just show that. Yeah. This is going to be the 7. Let me close all of this. 7th example. Okay, let's say I have 2D. Okay. Uh, I think we can wait maybe once Manjunath comes. Just because this example is going very critical. Okay, we can just we'll wait for a minute. Okay.
Sure. Okay.
Meanwhile, I'll have. Okay, let me just show you, right? So let's say I have a class which represents 2-dimension coordinates. So it has X as well as Y. I have just a single constructor which takes A and B both. And
Okay,
I'm
parameter as constructor.
right, yeah. This is a constructor with, okay. So I'm just going to give the wildcard, bounded wildcard demo and example I'm taking. So example is, this is a 2D class which takes X and Y. And this is a constructed, this is a non-generic class. Okay. Same, let's say I have a 3D class.
So
This is,
just the constructed declaration alone.
yes, yes.
Okay.
Yes, there is no generic. Okay.
No getter setter with that
Yeah, nothing,
class. Okay.
nothing.
Okay.
Because I haven't declared this as a private. Okay, so don't worry about it. I can
Okay.
still,
Yeah. Sure.
I can
Okay.
still access this within the package.
Package. Okay.
Now, what I'm saying is I declared a 3D, and because it extends 2D, I'm passing the X and Y coordinates to the right base class constructor. And here also, I'm declaring a 4D, which takes the fourth dimension here, and other 3 dimension I'm passing as a base class constructor. Fair enough. So one thing that we need to ensure is wildcard or bounded wildcard actually needs to be used wherever we see the class hierarchy. So that's the hierarchy that I've created. Okay, base class is 2D, then 3D is the child, and 4D, right, is another child of 3D. Fair enough? 3 hierarchy. Now, I have created a generic class to store the coordinates. And what I'm saying is it can store the coordinates of 2D onwards. Any class, let's say tomorrow, I'm going to create 5D or 6D. That can also be right feasible with this. That can also be possible with this. What I'm just trying to ensure is any class which is extending 2D, I should be able to use that as a type here. That's the meaning of it. Any class which extends 2D, I can use that as a type. And that's why 2D behaves like upper bound. 2D behaves like an upper bound for this type. Now moving on, I'm creating the type array, which will store all the coordinates. And this is the constructor I have put to take the type array and assign the reference. Just the constructor. Now, what I'm saying is, I have written a method, right, a class which has all the static method to show xy coordinate, xyz coordinate, and let's say all the coordinates for now. What it takes, the very first one takes the wildcard. There is no bound because coordinates can only be associated with a type which extends 2D. So the upper bound is already added here. Coordinates, if you see, can only be associated with a type which has upper bound as 2D. Now, if you see the bounded wildcard, I'm just giving the wildcard. There is no bound here. Clear? And by default, we'll get either we'll get 2D or subclass of 2D. Even if we get some subclass of 2D, I can get their xy coordinates and I can show it here. Fair enough? No issues, right? There shouldn't be any issue with this, correct? Now, what I'm saying is, what I did with this, with C, because I got the coordinate arrays, right? So with C, I got the axis of coordinates, and I'm iterating over the number of coordinates that I have, number of coordinate points, 1, 2, 3, 4. And then I'm printing their X and Y. And same thing I'm doing with XYG. But if you see, I have added a restriction here. This is a bounded wildcard. I cannot use or create XYG in the same way that I had written, right, for XY. So basically, what I'm trying to say is I cannot create something like this. Let's say N, okay? I cannot create something like this because somebody will pass 2D, right? Coordinates of 2D also. And in those cases, we will not have the Z information, correct? And that's why this method will go wrong. That's why this method will go wrong. Okay. Now, what happens? Let's say, okay, let's do this. Okay. We'll try. Let's say, okay. We'll try this. Okay. What we'll do is we'll try to okay. Now I did this. Nothing wrong with this method. We'll see how this method behaves. But for now, let's assume that that doesn't exist. What I'm trying to show you the example of the bounded wildcard. So here I gave the upper bound as 3D. So only 3D and 4D can be passed here because I can then only I can have at least 3 coordinates. In so all, I'm given the bound as 4D, which means only 4D can be passed. Okay. So we have to always remember that whatever bound, whether lower or upper bound that we are specifying, this bound itself is inclusive, which means I can still pass coordinates of 4D. But technically, if you ask me whether 4D extends 4D, a class extends itself, no, that doesn't happen. The way compiler checks is whether 4D is of the same type as the one that is mentioned here as a bound. So whether 4D is of type 4D, yes, that's correct. And that's why we are getting we'll be able to pass the 4D. Now, let's see what happens in the wildcard demo. I created a 2D. I provided, let's say, 4 coordinates. I'm just instantiating the chords. This is the generic class which stores the generic coordinates. And now I'm passing the 2D here because I instantiated with 2D. Fair enough. And I call the showXY methods. Okay. Now, let's say for 4D, I have passed, right? So with 2D, if I have instantiated with, right, 2D, I cannot pass these, right? I cannot call these methods because there is a upper bound check that has been added, and those checks will always happen on the compile time, always happen during the compile time. So you got the compilation error with this. Fair enough. Okay. Now, another one is I'm having 4D, and with 4D, I'll be able to call all 3 methods. Now let's first run this class. Wait. See, with unbounded type, the check already happened for the newly method. Where is that? So newly method that we created, because this is wildcard. Now wildcard, that compiler already knows that if it is wildcard, 2D can come, and that's why it says that, right? Cannot find symbol variable z in class this. I did not specify any type here. So that's why we cannot write a method like this. Okay, so which means in order to run this, we have to use something like this. So for example, XY coordinates, we got this is the content of 2D coordinates, this is the content of 4D coordinates, and then XYZ coordinates, we got XYZT coordinates, we got. Fair enough. XY coordinates also we got, right, for 4D. Same for 2D, we got these coordinates. Okay. And this was the original contents, right? So, okay. So coordinates we got, right? For XY, we got all the 4 coordinates. For 4D also, we got XY coordinates, XYZ coordinates, and XYZT coordinates. Any questions anybody has? Any questions? Okay. So we'll move on to what is called as generic method. How you can write the generic method altogether. Okay, so what we have to do is the type parameter declaration that needs to be done before the return type of the method. That's the main thing that we have to ensure. For generic class, the type parameter declaration was happening after the class name. Here, the type parameter declaration, that is this has to be before the return type of the method. Any questions anybody has with this? I'm creating as a is-in method, okay, which can take the object and it will take another array and it will check, the method will check whether this object reference, basically X, is present in the array or not. That's what we mean by is in. Now, in order to do the check whether it is present or not, what are the restrictions that we need to put? What we have put is the type will extend something called as comparable. And because comparable also is a generic class, so we also have to provide the type, what exactly that type information you are going to pass. So so basically this generic method takes two type parameter. One is a type which extends comparable. Another type V which extends the first one. Then only I'll be able to compare. Fair enough? So these are the extra restrictions that I can have with the method that I'm going to write. Okay, so this will come handy when you have to write some method that works on all, right? Works for all. And this will avoid your code duplication as well. This will, up to a lot of extent, avoid the code duplication. But the prime use why generic methods came or generics came is because of type safety. Now what I was able to do, I was able to iterate over this array. I was able to call the dot equals. Now dot equals method I can call because it is written in which class? It is written in object class. And whatever bound that I have given, it's applicable. It will be able to call the equals method on all the bounds that I have given on these types. So what I mean by this, right? I can declare a generic method within a non-generic class. My class might not be generic, but it can have a method which is generic. That's perfectly okay. And how we can do? So this is the, right? This is the mechanism to do. Now, same way, I think if we see, we'll see how generic constructor works, right? How can we create generic constructor even if my class is not generic? The type declaration will happen just before the name of the constructor, right? Just before the class name or the constructor name, you can say. We declared something t type with a bound that, okay, it will extend, it will be subclass of number. And now I am using t as an argument. If I don't declare any bounds here, I have to declare just t. Okay, if I don't have to declare bound, I have to declare something like just t. Because this is the type, now this became now official type for Java compiler. And after this, within this method, you can use it any number of times as you want. Okay. Okay, so what this constructor does, it just fetches, right? It takes any number or any subclass of number, and then it converts that to double because double is applicable for all, and it is storing it into the member variables. And I can have a non-generic method which will just return the value of those value of that non-generic member variable. Okay, fair enough. So this is what it made, right? This is how we declared, right, generic constructor. Same way. Okay, so we'll see how exactly we declare generic interfaces. I declared a generic interface called minmax, which finds min and max of, let's say, min and max of a class, right? Not on a class, I would say. Min and max, simple. Now, the implementation of this, let's say min max finder, I can have, this can take array, and out of the array, it can find the min max. This can take linked list also, right? So the min max finders, right, or another class you can create that will be that will be taking linked list. So what I'm saying is, we can write the very generic algorithm. Here what we are devising is how to find the min max that will be written within the class definition itself. Okay. Now, again, what we have to look at is the declaration part of the type. So type got declared here. All the boundary happened here. All the boundary conditions is added here. And this type is now passed as is while, right, to the method. This type is now used as is while declaring the method implementation. Fair enough? Now, whatever t value that I'm passing, this also satisfies the criteria of this guy interface. And that's why I'm passing this. Otherwise, we will get the compilation error. Remember, we did declare it once and we are passing it afterwards. We are trying to use the t afterwards. What we should not be doing is we declared it here also and we tried to declare it here also. That will not get compiled. Okay. I hope at least we got things clear. And let's see these examples, 8, 9, and 10. Any questions meanwhile? I'm happy.
Here, extend.
Uh-huh.
Can you share the screen?
Yeah, sure.
I think still can't see. Loading now. Yeah, I can see now. Here, actual t extends comparable is comparable. That comparator is there, right? I think that t extends comparable. I think
Comparable
this
is an interface, right? So whichever class which implements comparable will be able to use that as a type.
okay. Mainly, yeah, compare. Okay, then second one is like min-max of t. There we should give only generic. There you're saying comparable interface which implements that cannot be given, right? I think that throws error.
Yeah. So what I'm saying is, understand this. This statement itself is type declaration. Okay. Now, in order to use the generic interfaces, I have to pass the type parameter, and where we are specifying the interface name in the implement statement, the very first statement of the class, right? This is the very first statement, and where we provide the implements and the interface name. Now, what I'm saying is, you have to declare the type once. So this is the type declaration you did. And you can use it afterwards any time, right? As many times as you want. So for min max, I can use the type that I declared here. I can pass the same type. And because t satisfies this criteria, t extends comparable, there will not be any compilation error. One more thing.
Okay, we'll see some samples, right? Maybe.
Yes. We'll definitely see samples. One more thing okay, I'll emphasize here. Even if you want your min max finder class to be non-generic, but if you are implementing a generic interface, sorry. If you are implementing a generic interface, then you have to declare the type at this point, which means you by default made this class as generic. Now this type T can be used within this class also, or maybe in the base class also. Imagine you are doing it maybe, right? Instead of implements, you did it extends, right? So even if your subclass might not want to be uh, a generic class, but since it has to implement or extend a generic class, it has to declare the type parameter, and hence that subclass also became the generic class. Those type parameters can be used within your subclass also, and you can't prevent it. Fair enough? And let's take a look at the samples. So first we'll see the generic method, how exactly we can write the generic method. And if you see, this is the generic, non-generic class. I'm having a static method. This is generic. And what it takes is that it takes the array of a type, and it takes the another type as the element to search. And it will say that whether X is part of the array or not. Now, let's come to the main method. Here, while calling the main method, nowhere we told that what are the types that I'm going to pass is in, correct? Yes? Yes? Is in. I nowhere told, or I nowhere, right, declared that, okay, what's the type that I'm going to use? Whether I'm going to pass an integer with integer array, or I'm going to pass another integer with integer array, or I'm going to pass, right, something else, right? So for example, if you see string also, okay, let's go and see that, right? That will help you. If you see, integer implements comparable. Agree?
Okay.
Integer extends number and it implements comparable, and that's why we are able to pass it. That's why we are able to pass nums. We are able to
Where is
pass
is in method? Can we see is in method? I think
is
it's
in
top.
method here, right? Is in method is right here.
Okay, that's the same method. Okay, fine.
Is in method is same. If you see, this is a generic method. Declaration, type declaration happen before the return type. All the keywords that can happen before, that can be added before. Okay.
You have one thing. Now integer is the one which implements integer. Is there any other class which can be passed like other than the same class?
Okay. Yes, you can do that. You can do
Any
that.
such example, maybe that will bring in more clarity.
You mean what? Sorry. You mean
No, you
here?
showed example integer implements it's a comparator of itself, right? Maybe
Okay.
some other example in which other than integer, if other than the same class, if you can pass,
Okay.
maybe if it
Okay.
is
Okay.
possible.
Okay. So that's not possible. I'll show you. Okay. So let me take a new class. Let me create my own class. Okay. So class, let's say, custom type. Fair enough. Now I can make this also as a generic, but let's not do that, right? And let's say what I'm saying is, let's say it also stores that custom type stores an integer x, okay? And I can have a custom type, let's say constructor. Let me make it public. What I'm saying is, let's say int, or even take the reference a, and what I'm going to do is x equals to a. Okay, this is my custom custom type that I created. Now what I can do is I can instantiate the custom type. Okay, c1 equals to new custom type, and I can pass, let's say, 2 itself. Fair enough? Agree? Now, will I be able to call isIn method is in? Can I pass in?
That doesn't extend integer, right? If it extends integer, we can.
Yeah, that can be passed. If it extends, definitely that can be passed.
No,
You
no,
will
my
have,
question was, I think now we are passing same integer, suppose
oh,
a
okay, okay,
number
okay, okay. Okay.
T
Then
extends that comparator, that's the same method. If something other than the same method is something which I was trying to, no, actual comparator, if we can pass some other class, I think there I was getting some doubt if we can, how it works in that case.
which one? Sorry, you
Comparator of T, yeah, comparator or
comparable. Okay.
comparable of this way, and this we can pass for that.
Yes. Okay. So let's say I'll tell that T extends number or yes, let's do this, right? T extends a number. Internally, I'm going to use T. Internally, I'm going to use T. And let's say I did something like T. Now, what I did, I will have, okay? Okay, so I have to implement those methods, right? Okay, let's say I did it, right? For example, and let's say I get the type and type I will compare, and let's say, just a second, so I'll get that. What I'll do is I can do the double value, right? Because both will extend number. Now this type extends number and another thing will be also be number. So what I can do is if, okay, let's say, okay, P or yes, double get value. Okay. Now what I can do is return x dot double value. Okay. What I'm doing is if, right? If this dot get value, okay, is greater than O dot double value, right? Or maybe you can do that, right? So we can say what we can say is, wait, this will be a double cast. Okay, fair enough. Let's say I casted it to integer. Fine. Offset. Fair enough. Agree so far? Now, what I'll do is I'll use the custom type in the generic method. Let's say I used it in integers. Okay. And then let's say I passed it as 2. Now, if I say if is in, right, can I use C1 in nums? Right? Now, let's say what it says. Required type was T directly extends a comparable.
I think nums should also be custom type
okay. Yeah,
integer.
you're right. Both this should extend that guy, right? So, okay, let me create the, and I cannot create the array of this guy. Sure. Okay. The issue is that I made it, okay. Why did I make it generic? I don't have to make it generic. I can do is, I don't have to keep it generic, but unless I make it, I do. Just a second. So what I'm saying is, I should be able to create it. Now the thing is, this is now a generic class. Okay. This is now a generic class. I cannot create an array of it. That's one of the limitation of this guy. Okay, what if I have to do, what I have to do is, or let's do this, right? Just a second. What if I relax this condition? Okay, I can relax this because equals will be applicable for all. Fair enough? Now, what does this say? Again, right? There is no instance of type variable exists, so the custom type conforms to integer and inference variable T has incompatible bounds. What I'm saying is T is fine. T is fine. This extends comparable. This is also good. But what I'm not able to do is, what about V? Wait, did I save my code? Yes, no. Did I save this guy? Okay. Or if you, I mean, if you want something else to be added, I think I tried to create my own. But what I can do for you is, I can take another example of, for example, double, right? Double also does, right? It belongs to this guy. Okay. I can do it like 1.0, 2.0, 3.0, 4.0, and so on. Okay. Because that was a generic class. So if you want, if I can write 1.0 to denums, I should be able to do that. Okay. Whether, okay. But because I ended up creating a generic class, I cannot create the array of it. Okay. That's one of the limitation. The generic way of creating array is different. Okay. Fair enough. Denums should put.
Okay.
Okay. Now, if you see, double also implements comparable. If you see also, right, I can even do this. Can I do this? Is there any restriction? No. I can still do this because there is no restrictions on how exactly the relation between these two should be. It just says that this should extend this guy. Okay. Okay. If you see, right, this is a double, correct? And now this is a number, right? This is an integer array. How exactly this code is getting compiled? Any question? I mean, any answers? Any suggestions from your side? Why this code is getting compiled?
No, that extends number, I guess. I think so. This is getting compiled.
Which extends?
1.0 is a float or a numeric that extends the.
Yes. So 1.0 is a double. We can consider it as double. Okay. And because, okay, because it implements the comparable. Okay. And let me just change that, right? Extends T. Now, will I be able to get the code compiled? The answer is no. Because now my integer array, right? The array that I'm creating, integer, is not subclass of double. Got it?
Okay.
Okay. Other way to do is I can create number reference and one new integer. I can pass one. Now, wait. What does this say? Unnecessary boxing? Ah, that's fine. I want this to be boxed. Okay. Can I use this? The answer is no, because number does not implement comparable. Okay. Got it? Fair enough. Any questions? If I switch back to this, I'll be able to compile the code. Okay. Let me just remove this. is in, not in, I'm checking. And then similarly, I created a string array and then I called this, right? Whether it is equals or not. And because internally is in method calls the dot equals method on the object, it will say that, okay, 2 is in the strs. 7 is not in the strs. Got it? Let me run it. Okay. Double numbers, right? 2 is in numbers. I think this is a statement mismatch. I can get it corrected. Okay. So if you see, we are getting the same. I hope this is clear now, right? Manjunath? Yes, no, still have some doubts. I think there are some messages. Okay, fair enough. Now let's move on. Ninth example is about generic constructor. Okay. So let's see how generic constructors are there. For the constructor name, even if my class is not generic, I'm creating the constructor as generic. I'm just calling a double value. I'm just assigning that to double. And I'm just doing the so value. Same thing, it will work like, right? Charm. Double of this also will be shown. Double of this also will be shown, although it is of float type. Now,
Hello, Abhishek.
yes.
So actually, constructor should not be having any return type, right?
Yeah, so it's not a return type. It's a type declaration.
Or just the type declaration. Okay.
It is a type declaration. It's not a, I have been emphasizing, right? This statement, wherever you see, this is a type declaration. Wherever you see within the angle bracket, right? Less than and greater than. This is a type declaration. Type uses will be something like this. It will be without your
That's
angle
the
bracket. Mhm.
that's the parameterized argument, parameterized constructor, correct?
Yes, this is a parameterized. You are right.
Okay,
I'm
and
having
so the lefts, the type which you have declared,
Mhm.
that can be inbound also and outbound also. There is a two types, right?
It can be of lower bound also. It can be of
Lower, sorry, lower bound, upper bound. Yeah, I
yes,
missed it.
yes,
Yeah.
yes.
Okay.
Okay. So if you see how the compiler is inferring that 100 for 100, the constructor is automatically getting, we never specified, right? Whether I'm going to pass as an integer or a number or a double or a float. That is getting inferred by the compiler. Fair enough. So if you see, I did not pass it. Okay, this is 100 and even I'm able to pass the float. I can take another example and I'll be able to pass double. If you see, same thing. Got it? Okay. So I hope this is clear, right? And if somebody looks this from outside, they might not even know whether there is a constructor of generic type within this class. This is like a normal class, right?
Can you just open the constructor once? I think, yeah.
Mhm.
Instance number and the args. Okay, yeah.
Okay. Okay. Let's move on. Next, so we'll show you the interface, right? Generic interface. Min-max was the generic interface I created. I also gave some restriction. And then I'm creating a class, okay? Min-max finder. Okay. And this will be, right? By nature, this will be a generic class. Even if, right, if it implements the min-max, by nature, it will be of generic in nature. And if you see min-max finder, I have to declare the type here because this class is going to be generic. And nowhere else you would have seen that this statement, right? Less than t and greater than t. Nowhere else. Nowhere. Correct? So declaration always happens once. This type declaration also right happens once. In case of class, it will happen along with the. Just a second. Why my video is not coming up? Sorry about that. So okay. Is it here? Okay, fair enough. Why was someone here? Okay. So what I'm saying is, in case of class, the declaration happens just after the class name. In case of interface, the same declaration happen after the interface name. Okay, interface name is this, and the declaration type declaration will happen after it. In case of generic method, the declaration happens just before the method name. Same goes for a constructor. The declaration type declaration happens before the constructor name. Okay, so if you see the min max finder, I'm creating an array. It's of generic type T. The constructor takes the array reference, array object reference, and we are just storing that, assigning that reference to vals. And this is the method that I have overridden. And this method belongs to min-max interface. What I'm doing, I've just written a generic code. I'm taking the very first value. And because the value, this vals array is of type T, I can assign that value here. I'm iterating over till the var.length. And then I'm calling the compare to. Now, why I'm able to call the compare to? Because of this nature of comparable. Because T extends comparable, that's why compiler is okay with calling compare to on this vals.i. And once I see that, okay, if it is less than something which is less than the current term, I'm going to assign that value and I'm going to return the value. Okay, so this is how I have implemented the tmin. And this is how I have implemented the tmax similarly, right? Compared to if it returns greater than, which means it's greater than, and I got the maximum value. Any questions so far? Any questions so far? Okay. If we see this, right? I created integer array. I created the character array also. Same. Min max finder, I was able to declare of type integer and pass the integer array. I was able to declare of type character and I was able to pass the character array. And then I'm calling the min and max on these objects. That's it. Now you might be asking, what should be the min in case of characters? So it will be comparing the ASCII value of these. Okay. Yes.
Okay, comparing the ASCII values. Okay.
You see this, right? Compare to be called on the character. Now how character implements the compare to, right? It will invoke that.
Okay.
See this, minimum is A, maximum was R. The past minimum was, right? Fair enough. Okay. Any questions? No, thank you. So let me just go back to my slides.
That's the lexical comparison, right? Something they said, no?
Yes, yes. I said,
Okay.
right? ASCII code, you can say ASCII code comparison also, right?
Okay, ASCII code comparison. Okay, okay.
Now, what are the things that we cannot do with generic interfaces? So one, that is, I cannot have 2 times type declaration, right? I cannot have 2 times type declaration. One here and one here. This is not allowed. I cannot have a class which implements a generic, but I did not declare this type. This is also not possible. But what I can do is I can create a non-generic class using the non-generic version of the interface. This is allowed. Got it? This is allowed. What I told compiler that I'm going to create min-max finder, which will implement min-max of integer, right? And this is allowed, this works well. Any questions? No? Okay. Now let's talk about the generic class hierarchy. What happens? Let's say I have, this is the same generic class we have been using throughout. Will have a break? I think we'll just wrap up. Maybe I think that will be good. Is that okay? Maybe another 30 minutes. Sure. So what I'm saying is, let's say this is my generic class. I'm creating another generic class, Gen2 of type T. This is the type declaration. Don't think that this is not a type declaration. And I'm passing the same type to this guy. Okay. So the rule of thumb is any type arguments needed by the superclass must be passed by, right? Must be passed up the hierarchy by all the subclasses. For example, let's say I have Gen3 also, something like TV. I should be able to pass it to, and let's say this extends Gen2. I need to pass this T. I need to declare and I need to declare and I need to pass. Passing as in this guy I'm saying. Okay. Declaration I have already told you, right? All the any generic class that we extend, we have to pass that declare type parameter in the declaration. Passing as in if you see, I'm passing the T as a reference and I'm invoking base class constructor. So I have to pass all the way up and we'll see this in the example. Okay. For example, let's say I have two parameters. Let's say this is my Gen T and this is my Gen TV. Even if this Gen 2 doesn't need type parameter T, it doesn't use, right? It does not contain any of the, right? It does not have any of the members declared with type parameter T. Let's say, what if obj3? No, it doesn't have it. Still, its constructor needs to take these as an argument. Parameterized constructor needs to take this as an argument and it needs to pass the type which of the parent class T all the way, right? By calling its constructor. Got it? If you see this Gen2 class has nothing to do with to deal with T. It only cares about some other type. But what it needs to have is it needs to pass those things all the way up in the hierarchy. That's the rule of thumb for hierarchy. Any type arguments needed by generic superclass must be passed up. Okay. So we'll take also another example, right? A generic subclass example. I think this is the same example. Yes, no? Yes, this is the same example. We'll see. Okay. So let me just do that quickly. Okay. 11 and 12. Any doubt on this? Or you will it will get clear once you will switch back to the examples. Now, if you see this is my Gen class. Let me close all others. This is my Gen class. It is the same usual class. This is my Gen 2 class. It extends Gen of T and it takes TV as a parameter. I think, and then this is the hierarchy demo class. What I'm doing is string and string and integer I'm passing. I'm passing both the values string as well as integer. Now string got all the way passed to the gen class constructor here by invoking this. So string and integer. Then first it passed the string all the way up, and in the hierarchy demo, I'm calling both the methods, right? I'm able to call the parent class method also, like gen class methods, get obj, and this is gen2 class methods. I'm able to call both of them, and I'm able to get string as well as the integers printed. Clear? Let's take another example. And this example we'll see, right? Okay. I can have a subclass which can which can be of generic in nature. So this is generic subclass, but it extends non-generic class. That is still possible. Okay, so it can still extend the non-generic class, and that's possible. So in the hierarchy, I can have non-generic class as a parent and then generic class as a child. But I cannot have generic class as a parent and non-generic class as a child. That cannot be possible. So yes, what I did is we extended non-gen, and non-gen is nothing but it will have an integer constructor and then get num. It will return the number. And then gen class, it extends it, and then hence, right, it should take both the values. Otherwise, how will it pass to how the values will be set to the base class or base class constructor? So if you see, obj and I are getting passed here. I is getting called all the way up to the base class. OB is right, reference is getting stored into obj, and then this is another method. Now, if you see this, right, I'm able to create a string. This is my subclass, and I'm passing, right, invoking the constructor by calling string as well as integer, and I'm able to call those methods, get object and get number. Get number is from the base class, and get object is from the generic class. Same. Now, let's look at one last example. This is gen. Okay. This is gen2. It extends and super is getting called. Now, the instance of, right? Instance of. So how the references can be compared or assigned. And that's what we have done that check with doing the instance of. Okay. What I'm saying is, that I created in gen of integer, I created gen2 of integer, but now gen2 extends gen1. Okay, so if I do an instance of check for object 2, if you see object 2, whether it is instance of gen2, yes, and instance check needs to be done with a wildcard, because instance of, I mean, consider, right, when this statement will get executed, this will get executed during runtime. Runtime, there is no type parameter that exists, either wildcard or nothing. Okay, so that's why what I'm saying is it is checking whether I object of 2, right, I obj of 2, whether it is instance of gen2. Yes, because it was created out of gen2. This will return true. It will check whether I obj of 2, whether it is instance of gen of, right, gen of integer, whatever is being passed. So what this wildcard means is whatever your type is, so obj of obj2 is of integer type, whether it is instance of gen2 of integer or not. Yes, whether it is right, obj of 2 of integer, whether it is instance of gen of integer or not. And the answer will be yes, because gen of integer is a base class of gen2 of integer. Okay, so this also will print true. Same str object I created with the gen2 of string I created with the gen2. So this will also hold true for, right, test hold true for gen1 and gen2. That's correct, right? So str for str. If you see whether it is instance of gen 2, yes. Now, whether it is instance of gen, this will also we say this is instance of no. Wait. Whatever we create, yes. So this is correct. So str object 2 will be instance of gen 1 also, right? Now what we have is whether I object is instance of gen 2. And this will return false because I object is the object of parent class. And then I object will be definitely the instance of gen, correct? So if I run this, you will see all the answers. I obj of 2, right? Gen 2 object is instance of gen 2. Gen 2 object is also an instance of gen because gen 2 is a subclass. Gen 2 of integer is a subclass of gen of integer. Str object, it's an instance of gen 2. So it will be also an instance of gen. Then integer object, it will only be an instance of gen. So whatever parent-child relationship that we used to have in the non-generic world, the same will be applicable in the generic world also. Keep this thing in mind. That parent-child dependency or parent-child understanding, that base class can store the address of the child class, that understanding will hold true here also. But you need to find out, or we need to find out whether whether there is a base, right, parent child relationship between the two types or not. This means is that whether gen of integer is parent of gen 2 of integer or not. So in this case we got yes, it is a parent, it has a parent child relationship. Now I'm giving you a question. Can this gen of double, right, let's say dobj, will it, or let's say no, for that matter, let's say gen 2 of double. Okay, let's say I created, instantiated it like gen 2 and double. Let's say I pass this as a 80.0, 81.0, let's say. Now my question to you is dobj2 instance of gen of this? My question to you is dobj of 2 is instance of gen of question mark wildcard gen? I need answers, please. Yes, because gen wildcard means we are comparing the data type of gen 2 of double, whether it is right, it is an instance of gen of double or not. Now, what if I have to check something like this? So can I do this check? The answer is no. Okay, I cannot do this check. I cannot write this piece of code because this type does not exist during runtime. Thing I will be able to do is this will not compile. Okay, only thing I'll be able to do is just compare it with the wildcard. Okay, fair enough. Yes.
Okay, just compile with the wildcard.
Wildcard, or let's make it more interesting, right? Da, 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 da. Okay. Now, can I do it?
That will be wildcard and that, okay, parent class.
What if, will this work? Is it feasible? If this works, will this hold true? Yes or no?
So you are adding that upper bound thing.
Yes. Tell me. I need answers.
It should be possible because
Okay, and
question mark or nothing you told, but bounded question mark should be okay, I guess.
yes. It should be okay. But whether it will return true or false. Wait,
So
does it say error? No.
so only you
Oh, okay. Wait. Did I write it correct? Did I write it correct? Okay. Yes, I think we can't even do this during runtime. Sorry about this. Because all these bound check happened during the compile time. Sorry about my understanding. Okay. Because all these bound check happens at the compile time. Remember everything, right? Everything to do with the generics, all the checks, all the errors, right? I told this in the beginning also. All these things happen at the compile time. So at the runtime, the evaluation of the bound check, that will not happen. In fact, this itself will not exist, right? So we can only do up to this, not the other way. Clear? Okay.
okay, neither the lower bound, neither the upper bound.
Nothing. I can only use wildcard. Simple. Because that type information itself will not exist. Okay. Does not exist after compilation. Type information, whether it is extents or lower bound, upper bound, everything that doesn't exist after compilation. That's it. It gets replaced with the typecasting. Okay.
Also, Abhishek, one doubt. So, does the wildcard also represent as a object type? Means,
No. No.
okay,
If it would have been representing an object type, then this guy would have made as true. Correct? String
okay,
object, right? Sorry, integer object. I object of, right? Gen2 should have been made as true if it gets replaced with the object. Correct? So Gen2 is not, Gen2 still exists, right? Gen2 as a class still exists.
okay,
It's just that it says that whether it will just do the hierarchy check. Instance of is instance of only does the hierarchy check, and that's why wildcard is introduced, because the at runtime there is no type information. At runtime there is no type information, so you can, it is replaced with question mark, which means anything, and it will just check the hierarchy whether the class name of I object, whether it is in the parent or right, whether basically Gen2 is the parent of that or not. If Gen2 is not the parent, then it will return false, right? So basically instance of checks the parent child relationship. That's what we need to ensure. There is nothing that gets checked about the type. All that type checking happens during compile time always. Okay.
compile time. And also one more doubt. So, when so in many of the documentation we have seen in the generic, they pass as a T or V or something, right? So does that mean like that wildcard? What is the difference on that wildcard question mark symbol and the generic some T, capital T or V like that?
Just a second. If you see here, okay, not this. Stats is also a single. Huh. You see, I've done this, right? I've shown you this example, TNV,
Yes, yes.
right? So what's your question? Tell me.
Yeah, like so I was thinking, so instead of, can you also give, instead of T and V, you can make question mark question mark?
No. Declaration, I cannot give question mark here. This is type declaration. Declaration, this is like a type, right? I'm saying compiler that now, from now on, use T as a type. I can replace that with K also. But everywhere I have to change that to K. Okay? Everywhere I have to change that to K. This is a data type, new data type that asks compiler that you come up with, you start using this as a data type. That's it. That's the meaning of this.
Okay. So,
What
but
do you mean
when
by
the
question mark? This is
yeah,
like, if I don't declare, right? If I don't specify, I cannot specify question mark. This is a symbol, right? Not a letter. I can use any, it's a like declaring a variable name, right? Can you have a variable with question mark? No, right?
yes, we can't have. Okay. Yeah, because you mentioned means. Uh,
Wildcard as in wildcard is there to survive up to the runtime. Other than
okay,
that,
just
all TNV will get replaced during compile time. After compilation, there is no TNV. Okay. Another
okay.
thing, another thing during compilation, that question mark gets evaluated as a anything, right? No restrictions.
Mm-hmm. Okay, okay. Mm-hmm. Got it.
Got it? I hope things are clear at least. Okay. Yep. No. Any more doubt? Whatever doubts you have, you can ask. We showed you different examples. We showed you by running. We showed you how to write. We showed you what happens if I try to change something, right? I showed you different flavors of it, correct? Any questions anybody has? Okay. No? Manjunath or no? Thank you. So let me move on. Let me move on to the last leg of the generics. And that is okay. I gave you the generic subclass. Now, what are the generic restrictions? For example, I cannot create instances of the type that was declared as a generic. This is not allowed. And that's where you must be seeing that wherever I'm using this, I'm creating a parameterized constructor where I'm taking this as an argument. Okay. So I cannot create simply instance of this. Now, understand from the analogy, right?
So
This
you
is
meant to say default constructor is not allowed.
no. What
Okay.
I'm saying is you can't instantiate this guy.
Okay.
This is the problem.
Allocate the
This
instantiation.
is the
Okay.
problem
Okay.
because understand from the analogy when this statement will get executed. Runtime? Yes. At runtime, there is no type parameter T. So how will this statement get executed? Correct. So that's why this statement is invalid. Fair enough. Fair enough.
Okay, that's the invalid line. Okay.
Next.
That will also throw compile time error.
Yes, this is compile
Uh,
time. This will be
okay. Okay.
compilation. All of these will give you compilation errors. Okay. Now, we can't declare static members with generic type. I can't have it something like this. Okay. This is still valid. Oh, sorry. Both of them are invalid. My bad. My bad. Wait. Let me just cross check. I cannot have the static members. This is still valid. Okay. Because this type will get replaced after compilation, and whoever is using it, they will replace it with appropriate type, and that type will get replaced here. So this is valid, this is invalid. Static members cannot be created, but static methods can be created. And in fact, I had showed you that to you in the example. I can have static members which can take the type parameter. Fair enough? Fair enough?
Okay.
Type parameter and method parameters they can take, but it cannot have the members and return type, correct?
Yes. Members, yes, it cannot have. Correct. That's correct.
Okay. How, Abhishek, how about the access specifier part? Like public
They
or
will come before.
okay.
They will public, static, everything will come before. Okay.
Public or private or a default. Anything.
Right. Okay. Now, what are other restrictions? I cannot do array creation with generic type. Again, array creation will happen at the runtime, and that's why it's not allowed. Got it?
Okay. Array creation object generic type.
Okay. What other array restrictions I am saying? Okay. So one was this guy. I cannot create array of this guy. Also, I cannot create array of this guy. And that's why when I was doing the example of my custom integer, I cannot create array of that. That is invalid statement. But I can create it in a generic manner. This statement is still valid. I get a wildcard. Okay. This array, what exactly this array will hold? This array will hold, it will have 10 elements. Each element will store the reference of object of type gen. So that can be created. Okay, so this is the statement I should have used while doing the other example. Fair enough? Questions, concerns? No. Okay. So one last restriction we have. So we cannot have a generic class, right, which extends throwable. Okay. A generic class cannot extend throwable. This is not allowed. And what this means is that I cannot create a generic exception class. Okay. Fair enough.
Okay. Generic exception. Okay.
Okay.
So
So
can we also extend that exception class then?
it just says that
Oh,
throwable we should not extend. Other than that, we can extend.
okay. The super most class. Okay.
Why? Do you know why?
Uh, that's the maximum upper bound.
No.
Okay.
So if upper bound is there, right, I should be able to create those generic classes. What's the harm?
Yes. Okay.
Okay. Take that as an action item. Maybe we'll discuss that why. Why when throwable is not allowed. Okay. Now, that's it for today. I think we spent sufficient time going through generics. And I hope after this, you will be comfortable with any generic programs that you see. Agree? Yes, cool.
Sure.
Any other questions anybody has? Okay.
That arrays, can you scroll up? I think it was not a bit clear to me. Just one line, some small.
This guy.
Yes, yeah.
This
I
guy,
think
right?
generic integer, yeah, correct.
So remember this, right? This doesn't exist during runtime. Runtime, this is not there.
Question mark or nothing, right? Correct.
This is there. This will work.
First one or second one? I think I can't see the pointer where it is.
Oh, okay. First one will work. Sorry, will not work. And second one will work. Gave it, right?
But yeah, first one is like normal without generic. We write something, right? That should compile, right?
I didn't get.
Like generally you have to create some class or
Yeah,
like
so
here we are.
it's like, let's say I have ABC, let's say, this will compile, right? ABC, and I can
Yeah, that was,
do that correction, right? This will compile,
yes.
correct?
Yeah.
But with the type, it will not compile. I cannot create arrays of these types.
Okay. Okay. Then maybe
Still,
I'll
I can.
try some sample and
Yes. You
With,
should.
with the type, we cannot create, right? Okay.
Yes.
Okay. Even if instead of integer, if you mention T or V, it's not possible. Okay.
Oh, T. We shouldn't even put T here, right? T is
Okay.
always at the time of declaration,
Declaration.
type
Okay.
declaration during class, creating generic class or generic method or generic interface. Only those three places will have the T.
Okay. Okay. Only class and or method.
Whenever we try to use it,
Okay.
we will not have T and we will provide the actual reference. Now, even with the actual reference, will not be able to create this guy. But by just giving a question mark, we'll be able to bypass it and this will be allowed. Now, think of this it in this way, right? Gen of integer, right? This type does not exist in your this thing. This is syntactically incorrect. It's like syntactically incorrect. Tactically wrong.
Okay. Okay. Syntactically error. Okay.
Okay, syntax error, you will get compilation error. But because I gave the question mark, now it will be able to create a generic array which can hold the address of object of generic gen type. Okay, clear? Okay. One thing, I'll get the these things uploaded. I haven't also uploaded yesterday's class demo. I will get that also uploaded. Also, I will provide. Okay, one thing, right? I have so I plan to do 1.5 hour session in the afternoon for the tutorials. For example, whatever you did, if you are stuck, we can plan the tutorial session. There, I'll give you the hands-on. Where you are stuck, we'll get it resolved and then we'll move on. That's one way that I has planned. Now, if you have doubts, we can get that scheduled for today. If you don't have any doubts, we'll plan from the next week onwards. I think next week we'll have difficulty because next week the timing that I'm having, right, 9 to might not be feasible. We'll plan early. The Saturday Sunday schedule I'm talking about. We'll plan early slightly 7 and then we'll finish by 9:30. Okay, because I have to kind of be in be in a meeting that I cannot skip. Okay, so we'll plan that, but the planning of these week modules are like whatever have been given. Also for this today's class, I haven't given you assignment, so you will be posting you the assignments also. Plus, I'll also be sharing the serialization, deserialization example because that we did not work practical examples. Okay, that will help you understand the serialization, deserialization as well. Questions, concerns?
Okay. Only for the next week that
Yes.
timing is from the 7 to
Yes. Only for
9:30,
the-
right?
Yes.
Okay.
Only for the next week.
Okay.
That's why I'm intimating right before itself.
And for the
We'll
weekdays,
we'll have the classes, evening
we'll
classes.
have the classes from 8:30 only, right? Evening
You guys,
8:30.
if you guys comfortable to prepond it, I'll prepond it. I'm fine doing 8:30 also. I thought some of you used to have some meetings, right? So that's why I pushed it.
Yeah, Abhishek. Actually, for me, evening time, mostly that timing, right? It is bit difficult. That 8:30 onwards, that
Oh, okay.
office
Then
call starts. Yeah.
then I'll plan 7 then, right? Will that work?
No, if that's fine with
Yeah,
Manjunath and
yeah,
other.
that's why.
7 is fine for me. That's okay.
Okay, so then 7 I'll plan Tuesday and Thursday. Okay.
Okay, okay. Yeah.
Okay.
Thanks.
Any
Thanks.
any doubts that you guys have with respect to tutorials? Did you guys go through? Because see, the more you do hands-on, that will be very much I mean, I would say I will be very happy for doing those hands-on. The reason is you will get to learn. Okay, you will get to do those stuffs. The reason I did not give more assignments, as in like it. I don't want to make this as a burden. Okay, it's like, okay, it will be burden, and you have right set of things that are piled up. So what I'm saying is, the more you do, the more I'll give, the more we'll practice. Okay, so and the more we'll learn. That's the whole purpose. Okay, so thank you
Okay.
so much for joining today's class, and we'll wrap.
So next week,
Mhm.
means next week that what we have the plan to start. Yeah.
Yes, yes. So I think week 1 and 2, if you see, we'll cover definitely Tuesday. We'll cover the this thing collections. Okay. We'll also try to cover, because collections, I think most of us know how to use it. It's just that we need to right see it from the generics angle. Once we know the generics now, how differently we are seeing those collections. That is one. Also, we'll see when to use what, right? That's what will give you a brief on. Okay, so exactly which collection. So for example, tree set, when to use tree set, what are the pros, what's the internal data structure that gets used. So those right briefings will go through. We might not do examples of every scenarios there. Okay, because we all have done that, but definitely we'll have at the end of that, we'll have a project to work on.
So for the collection framework specifically, uh, during discussion, do we also, can you also please explain those that time complexity part, space
Yes,
complexity
yes,
part
yes,
for
yes,
okay,
yes. I will do that, because
okay, okay.
those are data structure types, right? Unless we
Yes,
know
yes.
the right the complexities, how will we explain? How will we justify which to use, which not to use, right?
Okay, okay. Also that that internal implementation of the hash map, those kind of a question.
Yeah. I mean,
Yeah.
definitely will.
Okay, okay. Actually, mostly they ask like that collision thing and all. Yeah.
Yes, definitely.
Okay, yeah. Thanks. Just to know. Yeah.
Anything from your side, Manjunath?
I think as of now we'll practice current today's one, and maybe next week I'll come back with questions. Yeah.
Sure. Thank you so much. Thanks for joining. We'll call it a wrap.